Hello and welcome. In this lesson, we're going to be going over the concepts of period and frequency and how to find period if given the frequency and how to find frequency if given the period. Let's begin. Please remember to pause or rewind the video as necessary. Period is the time it takes to go through one cycle. Frequency, on the other hand, is how many cycles occur in 1 second. Period is measured with a capital T, and frequency is described with a lowercase f. Period is the number of seconds for one cycle. How many seconds it takes to do one repetition, one cycle, one rotation, one cycle. Frequency, on the other hand, is the number of cycles per second. You all can see that these are just reciprocal concepts of each other, inverse concepts. And so that's exactly what these formulas represent. Period is the inverse of frequency, and frequency is the inverse of period. Remember, in your calculator, you're going to want to use either the button that says x to the -1 or 1 over x, okay? So for instance, if you had a frequency of 2 hertz and you were trying to find the period, you would go period equals 1 over 2 hertz. But instead of going 1 divided by 2, you could just simply go 2 and then hit your inverse button. And that is the same thing. So keep that in mind as you go through this exercise. Try to practice using the inverse key in your calculator. All right, let's begin. Number 1, a string vibrates at a frequency of 20 hertz. Well, if you're given hertz, Hz is the abbreviation for hertz, then you are given frequency. Okay, we're looking for period. Period is the question mark. We're given 20 hertz of frequency. The equation is period is the inverse of frequency. Now, to show your work, we're just simply going to plug in 1 over 20, but in our calculator, we're going to go 20 inverse. So have your calculator ready as you do these exercises. 20 inverse, and we get a period of 0.05 seconds. Number 2. A speaker vibrates at a frequency of 200 hertz. What is the period? Same problem as number 1, really, just different values. We're given, we're looking for period. We are given a frequency of 200 hertz. Period is the inverse of the frequency. So period is the inverse of 200. Let's go 200 inverse, and we get 0.005 seconds to complete one cycle, 5 thousandths of a second, essentially. Number 3. A swing has a period of 10 seconds. What is its frequency? So we're looking for frequency, and this time we're given the period. Frequency is now the inverse of the period, or we'll go 10 inverse. The inverse of 10 would be 0.1. 0.1 hertz. Now, 0.1 hertz means 0.1 cycles every second. So, or 1/10 of a cycle every second. So if it takes 10 seconds for the swing to go there and back again, it means that one cycle would happen in 1/10 of a cycle every single second. Number 4, a pendulum has a period of 0.3 seconds. What's the frequency? Looking for frequency, period is 0.3 seconds. Frequency is the inverse of period. Oops. Fix that. Let's go 0.3 inverse, and we get roughly about 3 1/3 hertz, or 3.3 cycles every second. Number 5, you want to describe the harmonic motion of a swing. You find out that it takes 2 seconds to complete one cycle. So we are given 2 seconds for one cycle. We're looking for period and frequency. Well, what are we given here? Well, the clue is in the unit, okay? Seconds goes with period, hertz goes with frequency, or cycles goes with frequency, or possibly vibrations also goes with frequency. So we're actually given the period of 2 seconds. So we'll just go ahead and write that down. But we need the frequency, and we have to take the inverse of the period to do that. So 1/2 would be 0.5 hertz, or a half a cycle every second. Number 6, an oscillator makes 4 vibrations in 1 second. Okay, so that's what we're given, 4 vibrations every second. What's the period and frequency? Okay, well, now what are we given here? Well, vibrations measures frequency. So we're actually given the frequency. But instead of writing 4 vibrations per second, we would write 4 cycles per second, or 4 hertz would be the proper unit for frequency. Since we're given frequency, we're going to use the inverse equation to find the period. And it's going to be 1/4, or 0.25 seconds. Number 7, a pendulum takes 0.5 seconds to complete one cycle. What's the pendulum's period and frequency? Well, 0.5 seconds per cycle would be the period. Half a second for each cycle is the period. The frequency, on the other hand, would be the inverse of that. So frequency is the inverse of 0.5. And if we go 0.5 inverse, we get 2 cycles per second, or 2 hertz. Number 8, it takes a pendulum 10 seconds to go through 2 cycles. We want to know A, the number of seconds for one cycle. B, we want to know the period. C, we want to know the frequency. Okay, well, part A we can do right now without a formula. If it takes 10 seconds to go through 2 cycles, that means it takes 5 seconds to go through 1 cycle. Just divide the 2. And what are you looking at? 5 seconds per cycle? Well, that would be the period. The period is 5 seconds, which means we need to still find the frequency. Frequency being the inverse of the period. And 1/5 would be 0.2 hertz. Finally, in number 9, an oscillator makes 360 vibrations in 3 minutes. We want to know A, vibrations in 1 minute, B, vibrations in 1 second, C, period, D, frequency. Okay, so first let's figure out A. If there's 360 vibrations in 3 minutes, just divide those two and you will get 120 vibrations in 1 minute. Next, part B, you're looking for the vibrations in 1 second. So if we take 120 vibrations in 1 minute, multiply by the fact that 1 minute, there are 60 seconds, which means we're dividing by 60, we will get 2 vibrations per second. Well, what is 2 vibrations per second? Well, ladies and gentlemen, that's the frequency, but we'll write it as 2 hertz instead. Finally, the period, just the inverse of the frequency, or